Okay, so this is actually another explanation for part one, number two, the one with the two large insulating plates. Now, another way to look at it is the net electric field from this plate is going to be equal to the charge density over 2 epsilon naught. And the electric field from plate 2 is going to be sigma, the charge density, over 2 epsilon naught. So that those are what the from this wherever at a point it'll end up being the net from this infinite sheet will be the charge density over 2 epsilon naught. Another key thing is to remember that infinite sheets, which were identifying these large parallel plates as infinite sheets because when they say large, they're referring to that these plates are so the length of these plates are so large, the distance a point away is insignificant. And so, if we look at the total electric field from 3, the electric field on 3, it's equal to the electric field here of plate 1, which is sigma over 2 epsilon naught. And it would be pointing that way, so we'll say positive. Here, the electric field would be pointing the other way, so we got to subtract that from the epsilon from plate 2, the net electric field. Therefore, this would equal 0. Now that's going to be the same thing for the electric field at 2. It'll essentially be the magnitude of this plate, which is here, minus the magnitude of the plate here, of plate 2. So that'll equal 0. Now, and a quick note, in the book it derives this equation for infinite sheets of electric field. So this is where I got the net electric field is equal to the charge density of the infinite sheet divided by 2 epsilon naught. So I think that was in the homework too, if I remember, that you could derive that equation. I'm not going to do that here because that's going to take way too much time. So now let's say for points 4 and 5, or for point 4, let's say for the magnitude of the electric field at point 4 is going to be sigma, the charge density divided by 2 epsilon naught. And because the electric field is pointing in the same direction here, we're going to say, we're going to add it. And so it would be, the magnitude here would be this plus this, which for E4 gives us sigma over epsilon naught. Now that's going to be the same for 4 and 5. Now you're wondering, well, what about E? Wouldn't that be the same thing but in the opposite direction? And you would be right, yes. But remember, it's asking for the magnitude. So although when we add E1, we'll end up getting an overall negative electric field, we want the magnitude of that. So it'll end up being the positive. It'll end up being this value, but positive, which is the same thing. Sigma over epsilon naught. So the E field in zone 1 is, at any point here, is going to be, the magnitude is sigma over epsilon naught. For zone 2 will be 0. For zone 3 will be sigma epsilon naught.